Hello, you are welcome. The question here under collision says that two objects X and Y move in opposite direction as shown below. Find the velocity of Y if X moves in its opposite direction with a velocity of 0.8 meter per second after collision. So now, these are two objects. X is moving in this direction with a velocity of 1.5 meter per second, while Y is moving in this opposite direction to X with a velocity of 3.2 meter per second. And then we are given the masses of X and Y. Now, for us to solve this, we don't just use the values as they are. We have to take direction into consideration. So let me write out the given quantities so that it will be easier for us to see. Now, if you look at it properly, you will see that the value of X, I'll call X the object 1 and I'll call Y the object 2. So I'm going to say M1, that is X represents 1 and Y represents 2. So M1 is 3 kilogram, that is the mass of X. And then U1, that's the velocity, initial velocity of X, is 1.5 meter per second. We are taking this as the original direction. Now, M2, that's the mass of Y, is 2 kilogram. Now, let me continue the parameters from this other side. Now, U2, that is the initial velocity of Y, is crucial here. Now, if you look at it, I'm taking the direction of X as a positive direction. So this is a positive direction. So the direction of Y now is going to be a negative direction. Hope you can see what I've just done. So this X is moving in this direction. So its velocity will take the positive direction of positive 1.5. This Y is in the opposite direction. So it's going to take a negative velocity. So the velocity of Y now will be minus 3.2 meter per second. Take note of that. When objects are in opposite direction, when one is taken as positive, the other direction has to be taken as negative, provided it is the opposite direction. So for Y, it is minus 3.2 meter per second because it is going in the opposite direction. That is how to handle problems on collision like this. Now, after collision, the final velocity of X will be V1 after collision. And we are told that X move in its opposite direction. So that means after collision, X is going in this opposite direction. Hope you are seeing it. X is no longer moving in this direction. It is now moving in this direction, which is a negative direction. Don't forget, this direction is a negative direction, while this direction is a positive direction. So we are told that after collision, X is going backward in its opposite direction, not in its original direction, but in its opposite direction, which is a negative direction. So we are going to take this 0.8 meter per second as a negative value. Take note of that important part. So this 0.8 meter per second is going to be negative. So minus 0.8 meter per second. And then the question says we should find the velocity of Y after the collision. So that is what we are asked to find. That we should find the velocity of Y. So I'm going to take that as V2 because it is the final velocity of Y. So I'll take that as V2, which is what we are looking for as question mark. Now that we have able to identify these parameters correctly, once you're able to get the direction correctly with negative signs and positive signs appropriately, then I'm sure you no have problem in applying the formula. And don't forget, the formula says m1, that is in collision now, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That is, the total momentum before collision is equal to the total momentum after collision. Don't forget, momentum is mass times velocity. So the total momentum of the two objects before they collided is equal to the total momentum of the two objects after they collided. So now we can substitute values and then get our answers. So let me substitute. M1 is 3. So I'm going to say 3 multiplied by U1 is 1.5, and then plus M2 is 2 kilogram, 2, multiplied by U2. U2 is negative 3.2. So it's going to be negative 3.2, negative 3.2. Don't forget this multiplied by negative 3.2. And that will be equal to M1, which remains 3 kg, 3, multiplied by V1. V1 is negative 0.8. Negative 0.8. And then plus M2, which is 2 kg. And then multiply by V2, which is what we are looking for. So with that now, we can simplify further. 3 multiplied by 1.5 will give us 4.5. And then 2 multiplied by negative 3.2 will give us negative 6.4. Don't forget, this negative sign, we remove this positive sign because negative multiplied by positive is negative. And that will be equal to 3 multiplied by negative 0.8 will give us negative 2.4. And then plus 2v2. So 4.5 minus 6.4 will give us negative 1.9. And that will be equal to negative 2.4 plus 2v2. So now if I continue with collection of like terms, let this negative 2.4 comes to this side, becomes positive 2.4. Don't forget, this negative 2.4, when it crosses to the left-hand side, it becomes a positive value. And then this negative 1.9 is still on this side. So the sign remains negative 1.9. It is still on the left-hand side. So we're not going to change the sign. It remains negative 1.9. And that will be equal to, we are left with only 2v2 here, 2v2. So simplifying further, I have negative 2.4 minus 1.9 is going to give me 0.5. And that will be equal to 2v2. I can now divide both sides by 2 and also divide this by 2. So that 2 will cancel 2. I have 2 cancelling 2 here, and then I have v2 left. Let me write the v2 first. So I'm going to write v2 is equal to 0.5 divided by 2 will give me 0.25 and meter per second. So this is the final velocity for y. Now, the value of y is positive. The value of, that is the final velocity for y is positive. And what does that tell us? That after the collision, y went in the positive direction. That is this direction, which is positive. So after collision, y went in this direction. So that is why we got a positive value. If we had got a negative value for the velocity of y, then we would have taken it that y continued in its original direction of the negative sign. So, but since our final answer is positive, it means that y went in this positive direction. So y went backward from its original position. That is in its opposite direction. So that is how to interpret both direction and velocity in momentum problems like this. Hope you enjoyed this video. Please don't forget to like and share this video so that others can learn from it. And don't forget to join me in my next video. Thank you for watching.